A typical watchmaker at that time would usually have his own workshop, and this was normally at the back of his house. It was a small business that required very specialist tools, many of which were made in Prescot and can be seen in this video. The watchmaker removes his wig, which is too expensive for him to wear in the workshop, and it would get in the way. He puts on his apron, which will protect his clothes, and a hat to cover his hair and stop the metal particles getting tangled in it. He tips out the pieces of brass and steel which are needed to make the different parts of the movement. He first has to make the top and bottom plates of the watch. To do this, he hammers the metal to thin and harden it. He scrapes off the hammer marks and then cuts it to shape. He marks out the holes needed for the pillars that hold the plates together, and then does the same for the holes needed for the bearings of the gears that make up the movement of the watch. The watchmaker drills the holes using a spade drill. The drill is turned by moving the bow backwards and forwards. He rivets the pillars to the bottom plate. The timekeeping part of a watch is called the balance, and the piece of metal that supports it is decorated. He marks out the pattern for the decoration on the balance cock. He drills holes so the fine saw blade can be inserted. He sharpens his engraving tool and cuts the surface of the metal away to finish the pattern. He now starts to make the different parts of the fusee. A fusee is a cone-shaped piece of metal which evens out the force of the mainspring. The mainspring gives more force when it is fully wound up. He cuts the brass body of a fusee until it is the right shape. He cuts a groove in it using a special tool called a fusee engine. This groove will guide the tiny chain used to connect the fusee to the miniature barrel that contains the driving or mainspring. The shape of the groove is controlled by the shape of this pattern. He polishes the fusee bearings to make them smooth so they will turn easily when fitted in the watch. This tool is a pinion engine. Pinions are small steel gears. This engine will cut the teeth in them. The pinion has a brass disc attached to it with notches round its edge. The number of notches is the number of teeth to be cut on the pinion. The watchmaker turns the cutter by hand and forces the pinion into the cutter using a screw. After each cut, he moves the pinion by one notch so the next tooth can be cut. The wheel cutting engine is the tool used to cut the teeth in the small brass gears used in the watch. The watchmaker clamps an uncut brass wheel in the engine. He checks it against a pointer and adjusts it until it runs true. The engine can cut gears with different numbers of teeth. The circle with the correct number is chosen for this gear. He turns the gear to cut the next tooth. When this gear is working in the watch, it will move the minute hand round the dial once every 60 minutes. He now has to make the verge. A verge drives the balance as it swings backwards and forwards. It is the part of the watch that ticks and counts the tiny parts of a minute. He marks the verge so it will fit the watch. He files it to the right size, using pieces of wood to support it. The verge is now very delicate and easily broken. He twists the verge to give it the right shape. He does more filing to thin the pieces that stand out. The watchmaker heats the verge until red hot and plunged into water. This sudden cooling hardens it. He then softens the verge slightly by heating to a lower temperature. He polishes it and fits it, then turns the brass collar. He makes the balance for the watch. This is the part that makes the watch keep time. He rivets it to the brass collar, which was attached to the verge. You can see the verge standing up above the balance. The balance will be attached to a tiny spring called a balance spring. The watchmaker makes the spring by winding a fine wire into a mould to give it the right shape. He heats the spring using a candle flame and charcoal to make it hard enough to be used, and then gives it a blue colour by gentle heating while it is held in a frame. The screw on the frame tells him when the right colour has been reached. He fixes the spring to the side of a tiny circular brass collar by a minute pin and then attaches it to the balance and verge. In 1790, very few screws were used in watches. He turns the screw to the right diameter. He forces this small end into a very hard threaded hole in a screw plate. This forces the metal of the screw into the shape of a thread. He can now fit all the parts together in the right order. He fits them together within the two plates we saw him make at the beginning. Personal supervision by the owner of each workshop ensured that the quality was high. Competition and a long tradition ensured the finest work was sent out. Prescot watchmakers at their best have never been surpassed anywhere in the world. He tries the wheels to make sure they work properly. He holds the plates together with tiny brass pins. He puts the balance in place and uses the screw you saw being made to hold on the balance cock. He winds the watch a little, and after many hours' work it comes to life. He fits the hands and checks them to make sure they will not touch. In this film we have seen one man making every part of the watch movement, but in 1790 this would have taken 103 different specialist workmen in dozens of different workshops. The complete watch would have taken a year or more to make from start to finish.